Hello again, students. You are with teacher Walter, and we are dealing with mathematics, senior 6. Last time we were on lesson 3. This is lesson 4. Lesson 3, we have tried to see the geometrical representation of a complex number, and we have also seen the modulus of a complex number. If I try to remind you about that, we have seen that every complex number z, which is equal to a plus bi, can be represented as a point or in the form of a point p, which is equal to a, b. And then this point a, b is the geometrical representation. We call it, this is called the geometric form of the complex number, the geometric form of this complex number z. So I have also tried to show you how we can represent this. We have tried to represent this in the Argon diagram, where we have seen that a have to go to the real axis and now b have to be on the imaginary axis. This is b, which is the imaginary part, and then if we link them together, we have a point here that we have called p of coordinates a, b, and this is also representing the complex number z, which is equal to a plus bi. So I have also reminded you last time that we have here the origin, and then from the origin to the point p, we have seen that there is this distance. This distance, we called it the modulus of z. We have called it the modulus of z, and we have seen that the modulus of z, or the absolute value of z, equals to absolute value of z or r, and this equals to the square roots of the real part squared plus the imaginary part squared. This is how we have found the modulus or the absolute value of every complex number z, which is equal to a plus bi. Now, on the fourth lesson, I'm going to help you to understand how to do some operations in the set of complex numbers. We have now, the new lesson is operations in the set of complex numbers, operations in C. Now, here we will start with one, which is addition, and we take it with subtraction, addition and subtraction of complex numbers. With addition and subtraction of complex numbers, how do we do that? We shall now have here examples. We have here example number 1. Example number 1, we have two complex numbers and we have to do the difference. That is 2 plus 3i, we can take it as we want, minus 5 plus I. When we are asked to do the sum of these two complex numbers, we start by first with the sum, which means addition. When we are adding these two complex numbers, we know one thing. We have to first put together the like terms. We shall add the like terms, which means what? We have here numbers which are with the real parts, and we have other numbers which are with the imaginary parts. Here what we do, we add the real parts together and we add also the imaginary part together, which means that we just add the like terms. We simply do what? We have 2 plus 3i. If we remove the brackets, we have 5 plus I. And then to do this, we have to do what? What we do is just to add the real parts together, and here we shall have 2 plus another real part, which is 5. Here I have corrected the like terms, plus 3i plus, here it's like there is 1 times I. There we have 3 plus 1 times now I. So the like terms are these ones having I, which means the imaginary parts, and we have here the real parts. So when we are adding, we first add the real parts together, and we lastly add the imaginary parts together. And finally, here we shall find what? 2 plus 5, which are all the real parts, we shall get now 7, plus 3 plus 1, which are the imaginary parts, and we shall get 4i here. So when we take these two complex numbers, we add them, we get another complex number, which is z plus I, 4i. So which means that whenever you add two complex number, you get another complex number. We can now go for the second example. So we was going to go for number 2, example number 2, whereby we can now take an example of subtracting two complex numbers. I will here give you an example. We have 5 minus 4i minus 3 plus 2i. So what do we do here? When we are to subtract, we also do the same as we have done for the addition. What we do, we also subtract two real numbers that are there, and we also subtract together the imaginary part that we have there, which means we again correct together the like terms. The like terms will be the real parts and the imaginary parts. Here we go. We shall have now 5. You can immediately do it. Minus 3, which means you have just done the subtraction between the two real parts. This is real, this is another real. So we do now all the real parts, we subtract them. Then plus the imaginary part together also. That will be negative 4, negative 2i, which means we do the difference of the imaginary parts as we have done also the difference of the real parts. And then here we shall get 5 minus 3, which will give us 2, plus negative 4, negative 2, which will give us negative 6i. And finally here we shall get 2, negative 6i. So this will be the solution for this. As well as you can first remove the brackets, and then you also correct like terms by subtracting them together. But here it's a good example whereby we put the real parts together and the imaginary parts together. We go for now, this was this example number 2 on addition and subtraction. We can now do multiplication of two complex numbers. About multiplication, that is now number 2. Of the operations, we have multiplication of complex numbers. Now, what do we do now when we are multiplying two complex numbers? Before we go for the multiplication of two complex numbers, I have to remind you one thing. We shall remember that we have seen that I squared equals to negative 1, which means that whenever we have I squared, we shall get now negative 1. And we have seen also that I equals to square roots of negative 1, which means that this will be very useful when we are multiplying, because remember we shall have two imaginary parts, and if we multiply them we shall have I squared. So to simplify it, we shall put there negative 1. So as an example also about multiplication, if we immediately go to the step, example number 1, we shall multiply negative 4i times 2 plus 2i, and we shall do another second example here, which will be 2 plus 3i factor 5 plus I. So these two examples will serve us for the best. Number 1, we have to multiply. So what do we do to multiply? We can use here distributivity rule. You know about the distributivity rule, we first distribute this. We take this, we distribute multiplication over addition. That is negative 4i times 2. And this will give us negative 8i. And we again distribute negative 4i times 2i, which will give us negative 8i squared. Still here, we have one thing. We have to remember that I squared equals to negative 1, as I have said. So here we shall have now negative 8i, negative 8 times negative 1, because I squared equals to negative 1. And then finally, we shall have negative 8i plus 8, because negative times negative. So this will be the solution. Now, some of my students will have a confusion here, asking me, why have I started now with the imaginary part instead of starting with the real part? Here I have to remove the confusion, telling you that addition is always commutative. Whether you start with the real part, whether you start with the imaginary part, it is the same thing. So negative 8i plus 8 is the same as writing 8 negative 8i. This is the same number because addition is always commutative. We go now for the second example, which is kind of different from the first one. The first one, we have been able to remove the bracket by applying the distributivity rule. So it is the same here as what we are going to do. Here also, we shall use the same what property of distributivity. You can see, if we take this, we multiply again, we extend the operation, we expand. This is 2 times 5, and we get 10. And then we have 2 again times I, we shall get here plus 2i. So we have 2, for 2 is over, we again now have to distribute 3i over 5. It is now 3i times 5, we get plus 15i. So we have also 3i times I, which will give us plus 3i squared. Again, reaching there, we have to know one thing. First of all, we have these two like terms. Because they are all having I, we can add them. But we also have here 3i squared, which is not even an imaginary part. But we have to remember that I squared equals to negative 1. So we immediately have to say that it's 10 plus 2i plus 15i, then negative 3. Why is it negative 3? Because we remember that I squared is negative 1. Dear colleagues, now, finally, what we do is the normal addition of complex numbers. And we have seen that as we are adding, this is like we have two complex numbers. We add the like terms. And there, what we do, we have 10, negative 3, because they are all real parts. And we have 2i plus 15i, because they are all the imaginary parts. And lastly, we shall have 10 minus 3, which is 7. And then here we have 2i plus 15i, which gives us plus 17i. And this is now our new complex number, which is coming from the product we have here. So we are going to go next to the division of two complex numbers. So the fourth operation of the complex numbers, it is division. Division of complex numbers. While dividing two complex numbers, there is one thing that we have to remember. We have what we call as a remark or a notice. We have to I have to remind you one thing. There is what we call the conjugate of a complex number. Every complex number z of the form a plus bi has what we call its conjugate, has what we call the complex conjugate. The complex conjugate, or the conjugate of the complex number z, is z bar. We call it the complex conjugate of z, and this will be a minus bi. What does it mean? It means that when you are finding the conjugate of a complex number, you have to only change the sign of the imaginary part. The real part remain unchanged. This means that, for example, if we have a complex number z, first example, if I have 2 minus 4i, the conjugate of this one, the conjugate of this one, the conjugate of this complex number will be 2 plus 4i. What I do is just I change the sign of the imaginary part. If it was negative, it will become positive. If it was positive, it will become also negative. This is the conjugate of a complex number, which is called the complex conjugate, which is also another complex number. Number 2, if I have, for example, a complex number z which is equal to negative 2i, if I find the conjugate of it, this conjugate will be equal to 2i. Why? It is 2i because I change only the sign of the imaginary part. I don't touch the real part. And here the real part was 0, which means I only change the sign of the imaginary part and get 2i. Number 3, which can be various example, it's like I have 5. If I have a complex number 5 and I am to find its conjugate, the conjugate of 5 or the complex number z which is equal to 5 will be equal to 5. Many students will ask me, why haven't I written negative 5? I have not written negative 5 because 5 is a real number, and when it is a real number, it only has one real part. It doesn't have the imaginary part because z here will be equal to 0. So because we change the imaginary part sign and we don't have it here, we shall now keep it as 5. So the conjugate of 5 is always 5. So I think here everyone have understood how we find the conjugate of a complex number. It's just changing the sign over the imaginary part. So for division of two complex numbers, we shall need this. So how do we do now? Let us have also some examples about this. We go on with division of two complex numbers. We have here to consider two examples. The first example I will give you, it's an example here. I have I have 3 plus 4i over 1 negative I. So here we have how many numbers? We have two complex numbers and we have to find their quotient. We have to divide them. How now do we find the division of two complex numbers? To find the quotient, here what do? We shall now do what? We have 3 plus 4i and we have here 1 negative I. What do? We just take this number and we multiply on both sides by the conjugate of the complex number which is at the denominator. What does it mean? We have here the denominator is 1 plus I. Its conjugate will be 1 plus I. So we always multiply on both sides, on both numerator and the denominator. So here we have now to multiply on with the same thing, which means that it doesn't affect the number, because if we simplify, we come back to the number we have here. So here we shall get now 3 plus 4i times 1 plus I over 1 minus I times 1 plus I. Here I have to remind you one thing, student, which will help you to make these things very easy. So to help you to understand this more, we shall have that there is a property of the conjugate which says that when you take the the complex number a plus bi times its conjugate, which is a minus bi, this property will tell you that you have here to find what? You immediately find that it is a squared plus b squared. When you are finding the product of a number and its conjugate, you simply have to do what? To take the square root, or I mean the square of its imaginary part and the square of its real part. So that's why we have a squared plus b squared. This means that if I'm finding, for example, a complex number, if I have an example here, if I have a complex number 2 plus 1 factor its conjugate, which is 2 minus I don't have to struggle with it. I immediately have to find what? I take 2 squared plus its real part also squared. The real part is 1, I take 1 squared. It's like A is equal to 2 and B is equal to 1 from the beginning here. And then here we shall get 4 plus 1, which is 5. So we shall use the same theory here, because we have here at the denominator, we have the number and its conjugate. Remember, we have multiplied the conjugate on both sides of the fraction we're having here. So this will be equal to what? We shall have here now, we do normal multiplication as we have run it. We use the distribution property, distributivity property, and this here 3 times 1 will give us 3. 3 times 3i, we have now 3i. 4i times 1, we get 4i. 4i times I, we get now plus 4i squared. Plus 4i squared. We divide by what now? Because we have now a number and its conjugate, we shall immediately write 1 squared plus 1 squared. And now if we simplify the things, we shall have here, because we have here, it should have been the 4i squared, because it was 4i times I. And then when we have I squared, we can immediately change it and it is -1, because I squared equals to -1. This to make things simple. And then here it will be 3 minus -4, and this will be -1. We have here the like terms here, which is 3i plus 4i, and this will be plus 7i. We divide by 1 plus 1, which will give us 2. And here we shall have -1 over 2 plus 7 over 2i. So even though these are fractions, but all fractions are also real numbers, and it doesn't confuse. So we have here the imaginary part, the real part, which is -1 over 2, and we have here the imaginary part, which is 7 over 2, and this is the complex numbers which is coming from this quotient. I have to give you another second example, which will be more easier than this. The second example will be 1. I can take you through like 1 plus 7i over 2i. So this is somehow simpler than what we were doing. You will see that here there is no real part, but there is only the imaginary part. What do we do now? We no longer need to multiply with the conjugate as usual, but what we do, we just multiply with I. Because here this is the imaginary part, there is no real part. So we have now 1 plus 7i, we multiply with I over 2i times I. This means that I have tried to multiply by I with I on both sides. And this means I will get what? I will just distribute this. I get 1 times I, and this is I. 7i times I, which makes it 7i squared, and this will make it -7 over 2i times I, which will be 2i squared. And you can see it is -7 plus I over -2. Why is it -2? Because I squared equals to -1. And then here we can see immediately that will be 7 over 2 plus, or cause of this negative, it will be -I over 2. And this is now the resulting complex number from this division. So within division there should be 2 cases, where we need to multiply by I and where we need to multiply by the complex conjugate of the complex number on the denominator. So this is all about division, and we have seen so far addition, subtraction, multiplication, and division of complex numbers. Students, for your evaluation, you will do this. If you want to evaluate yourself, try to do this. You have to operate the following. Number 1, you work on this. Find this. Number 2, for your evaluation, try to do this. 2i times 1 over 2 plus 2 over 4i. Try to find this. Number 3, you will just work on this. It is 4 plus 5i divided by 1 plus I. And number 4, lastly, you will do this. It is 7 minus 8i minus 2 minus 5i. Lastly, number 5 is about addition. It's 1 plus I plus 5 plus 3i. Students, you will try this exercise to evaluate your work and how you will be successful. And I'm now inviting you for the next lesson, which will be lesson 5 about complex numbers. And for more details, notes, exercise, and evaluation, as well as tests, you will visit our website, which is www.ubumenyi.net. Or you can also visit our YouTube channel, which is Ikaramu TV. You should not forget to subscribe as well as to share for you to get more other additional videos that will be made. Thank you very much. We're with Teacher Walter. I invite you for the next lesson 5. Thank you.